We'll now look at ways to graph other types of data that's not necessarily in a grouped frequency distribution. And the first one we'll look at is a bar graph. Bar graphs are something that you're most likely familiar with, but let's kind of refine exactly what we mean. First, bar graphs are only used for qualitative data. We want this kind of categorical data rather than numerical. Next, bars can be either horizontal or vertical. And this is really kind of a personal preference on whether you prefer a vertical bar graph or a horizontal bar graph. Finally, the bars need to be uniform width and evenly spaced. In a histogram, all of our vertical bars needed to touch. In a bar graph, they actually should not touch. We should leave an amount of space between the bars, and this should be a uniform space throughout the graph. So now let's do an example. Here's a list of some colors where we did a survey and asked people what their favorite color was. The numbers next to the colors are the number of people that picked a particular thing. So for an example, 4 people stated purple was their favorite, 6 people said blue, etc. And now we want to form a bar graph. So we'll draw our axes, and this time on the x-axis we need colors. I'm going to use just the first initial for each color, P, B, G, R, and O. And the vertical axis, the y-axis, should be our frequency. So 1, 2, 3, 4, 5, 6, and 7. And now we're going to do vertical bars. 4 people said purple, so we'll draw a bar up to 4. Blue was 6, so we'll go up to 6. Green is 7, so we move all the way up to 7. Red is 3. And then orange was 5. So we have our bar graph. Note that the bars do have spaces between them, and the bars should be the same width, and these spaces should be the same as well. It's not in this graph because I did it by hand, and well, no one's perfect, but we did approximate the best that we could. The next graph we'll look at is called a Pareto chart. And a Pareto chart is a particular type of bar graph. So it is a bar graph, it's just a particular type. And in a Pareto chart, the bars are arranged in decreasing height. So we do actually want the first bar in our bar graph to be the tallest, and then we move them down accordingly. So let's do an example. Here we have the same data we had before with the different colors and people's different favorite color, but this time instead of a bar graph, we want to do a Pareto chart. So the main thing is to order these according to frequency. Green needs to be first since there's 7. We then have blue, then orange, purple, and finally red. Then, whenever we start to graph our bars, green goes all the way up to 7, blue is at 6, orange is at 5, purple's at 4, and red is at 3. So the Pareto chart starts with the highest and then goes down as we move to the right. The last type of graph we'll look at here is called a pie chart. Pie charts are something that are also very commonly done, and another name for them would be a circle graph. In a pie chart, we use wedges of a circle to display proportional parts. So pie charts are usually done as a percentage rather than a frequency. Before, for instance, in our data, we had the fact that 4 people stated that their favorite color was purple. But when we're dealing with a pie chart, instead of wanting to know how many people stated purple, we would want to know the percentage of people. Here we have the same data with colors, but this time we've converted to percentage. So now let's try to actually graph these. And it doesn't really matter what order we graph them in. Usually starting to graph numbers that are close to 25 or 50 or something like that tend to be a little bit easier. So I'm going to start with this 24% that we know is blue. So I will shade this part blue to indicate that that's the blue color. 28% is green, so we'll shade that part green. We've now covered blue and green. Orange is 20%, and 20% is going to be approximately 1/5. We'll say there. And this was orange. We then have purple, which is 16, and red, which is 12. So we need our purple section to be a little bit thicker than our red. And you'll notice I just approximated each one of these percentages. In general, we could have made these exact. For instance, red is 12% times 360 degrees in a circle. And if we do that, we would get 43.2. So if we wanted to do red, we should do 43.2 degrees if we wanted to make this more exact.